Hi, Dr. Carter here. Welcome to Lake Abert in Eastern Oregon. We're just about 20 miles north of Lakeview now. Why are we stopped here? Depends which lecture we're looking at. If we're in a volcanology lecture, we are seeing a absolutely stunning example of flood basalts. That entire cliff is comprised of lava flows, as is everything above me. This is your flood Basalt Province. To give you a sense of the scale, this covers a good chunk of the eastern part of Oregon and a good chunk of the eastern part of Washington, and Washington is still over 200 miles away from here, to give you just that kind of sense of scale of how huge these lava flows travel. Now, hopefully you've already got enough igneous rocks teaching to basically recognize that dark-colored igneous rocks are basalt. And yes, you can definitely get large igneous provinces with felsic rocks, but these extensive lava flows traveling tens, even some places hundreds of miles, can only really happen with a very runny lava with basalt. Exactly how this took place is still, let's just say, up for debate. This is actually not the largest of the flood basalt provinces. There's one in Siberia that's much bigger. There's one in southern India that's much bigger. There's a couple other these lips, as we call them, large igneous provinces in the ocean that form massive plateaus. And the ones in the ocean might not form by the same mechanisms that the ones on the continent, so crust form. There's a lot of unknown here. But they are absolutely spectacular. Spectacular to look at, witness, and be a part of. Now, the second feature we see here is a fault. I talked about this in an earlier video about this is the Abert Rim, one of the best exposed normal faults anywhere really in the world. Normal faults tend to create steep slopes, and you can see even on this steep slope there is a bit of mass wasting, but what's stunning is, you can really just see the offset here, such spectacular fashion. There it is, that steep slope dipping at about, dipping at about 45 degrees or something like that. And then if you look across the valley, across this utterly spectacular lake, you can see another tilted slope, indicating that we are in a half graben. So the bedrock on that slope continues below the valley, what we see here as the valley floor, and this has since filled up with sediment eroded from this side and that side of the valley. At points, this lake's been quite a bit bigger during the last ice age. There was a bit more runoff from the glaciers, and this took up quite a bit more space. Space of the shoreline is much higher. I don't see any paleo shorelines here, but I believe they must exist. I think I might see a couple maybe out in the distance there. You can kind of see a little escarpment way off in the distance. That might be the paleo shoreline on the other side there. It's really hard to tell. It's not exactly level. Well, yeah, I see escarpment, so, yeah. And what you see now is a very small, very shallow salt lake, and this is an Endocaric basin, so all those chemical weathering products are in the water evaporates, and as it evaporates, the chemical weathering products, halite and gypsum are probably the most primary things here, end up crystallizing and precipitating, giving this sort of beautiful white salt flat we have out here during drier spells. And again, you can really see the normal fault. Very few places are normal faults this obvious, but this is you're looking at a normal fault when you look at a feature like this.